So today we've been tasked with finding the parametric equation given a line of intersection of the planes. Planes P and Q. They don't have to be named P and Q, but they're arbitrarily for clarity's sake. So to start off, we need to find, well, if you want to attempt this problem on your own, you really just have to find the cross product and then solve a system of equations. And hopefully that's enough to get you going. But if you want further detail, so we're first going to find the normal vector of both of these. So the normal vector of P is the coefficients of each variable. So that would be 1, 2, and 3. And then the coefficient, or the normal vector of Q is the coefficients of each variable, which is 1, -1, and 1. So then we take the cross product of them, which we set up a 3x3, or not a 3x3, but, well, technically, anyways, we set up a matrix. And then we figure out the determinant. So 2 minus this -3 I hat minus j, which is 1 minus 3 j hat, plus, and then k is -1 minus 2 k. And then after we simplify this, turn this to a plus, we have 5i plus 2j minus 3k. So now that we have the cross product, and if you're unsure of what exactly the cross product is, it's basically, so these are two orthogonal vectors. Orthogonal meaning that they're perpendicular, they form right angles. So in a very general or like brief overview, so say that this is where P is, and then say that this line is where Q is. So they're both orthogonal to where their respective planes are. The cross product is basically another line which comes out at another 90-degree angle. And this isn't going to be a great drawing, but imagine this is a parallelogram. The length of this cross product is going to be equal to the area of this parallelogram. So use it as you will. It's not super descriptive, but you can think on it and hopefully begin to understand it more. So we do have the cross product of these two vectors. So now we just have to solve the system of equations that we were given at the beginning, which is these two. So I'm going to start by setting z equal to 0, since the 3 and the 8 don't look too good. So we'll go over here. Okay, so let's get rid of the c. And these will both just be equal to 8. So let's say x is equal to 8 plus y. So 8 plus y plus 2y is going to be equal to 8. So this will be 8 plus 3y equals 8. These cancel. So this will be a 0, so y is equal to 0. And then x equals 8. And then if you're confused, just plug in this 0 for y and either of these, and then x will equal 8. So now we have everything we need to set up this parametric equation. So basically the parametric equation is like a scalar format of how this line is going to behave. So in this case, we already have the t values. So x is going to be equal to 5t, y is going to be equal to 2t, and then z is going to be equal to -3t, where 5, 2, and -3, the t's are the scalars attached to each of these coefficients, which is going to be the orthogonal normal vector to this equation. And then we have to take the points of origin. So the zeros, think of it as this if it helps you out. And then we have an 8. So we are going to be starting at 8. So hopefully this helps you understand a little bit. Hopefully it didn't confuse you on the cross products or why the parametric equation looks like this. And just for some further detail, if you wanted to turn this into a symmetric equation, you would just have to make it so t is equal to the variables. So for example, t equal, if we solve for x minus 8 equals 5t, so x minus 8 over 5 is equal to t. So we just set this over here, and then for y and z, it's pretty self-explanatory. Y over 2 is equal to negative z over 3, and this would be just solving for t again.